Yeah, there we go. Okay. So it looks like this. Okay. So wait a minute here. So today, eukaryotes, viruses, and then we'll have the quiz on Monday, the 24th. So yeah, you have a week from today to get those 10 cards done. Okay. All right. So yeah. All right. So everybody cool with that? A week from today is your next Quizzy Wizzy. All right. Good. All right. Does that answer your question? Okay. Cool. Okay. Yeah.
For the disease course, so it says 11 through 20, those are already, is it just 11, 20?
11 through 20. So disease 11, disease 12, disease 13,
And then
disease
the rest.
14.
So it's more than? Or is it in
What?
the total? Is it in the total 10 cards?
Yeah, 11 to 20 is 10 cards.
Right, but then we have 29 to 38.
The following week, yeah.
Oh,
Oh yeah, you're gonna be doing cards.
No, yeah,
Yeah.
I'm just saying, but for those first 10, which is 11 to 20 on Monday, correct? And then the following is the following.
Correct. So if you just follow this here, so here, and then see how March 27th it says make disease cards for 29 through 38. And then we'll have a quiz on Monday, and then it says make disease cards for 45 through 51.
I got
Okay.
a question. Do you mean like, what about that space between 20 and 29? Is that what you're talking about? Like 21, 22, 23? Do we do those disease cards?
For this next disease?
We're not going in order.
Yeah, we're not going to go in order.
Oh, okay.
Yeah. That's okay.
Oh, yeah.
If we're talking about viruses, let's do viruses, right?
Gotcha, okay.
Yeah, okay.
10 pieces.
Yeah. Yeah.
21 and 20 is down there.
What? Not yet, but we'll get it down here. Look at that. Yeah. I've done this before. I'd rather have you do the diseases that when we're talking about most important. Does that make sense? Are we going to go linearly? No. But will we get them all done? See, yes, we will. So, yeah. So, you know, you can map this out. It all works. Did I answer your question?
Yes.
Okay, cool. Good. Any other questions on the schedule? Okay. All right. So, let's go. I don't want that class. I want this class. There we go. Yeah. Where all the cool kids are, right? Okay. Notice I've got midterm 2 review up. Okay. This unit has 30 cards in it. Almost 30 cards in it. Not quite. Okay. So what does this mean? Start making the mama sheets. Have you talked in lab about mama sheets yet? Okay, well we're going to talk right now. Huh? Those are sheets that you use that have all of the information on that summarize what you're doing. So if you notice on this, so you're going to need them when you do your unknowns. Okay? Question? You're looking at me like I'm speaking another language. No. You good? Okay. All right. Here's the etiological agent. Here's all the diseases and the system. Okay? So this is essentially a mama sheet. We're going to do bigger mama sheets towards the end of the semester in lab and in lecture. And the reason mama sheets, because you come to them for everything. This is your kind of list of everything that you have, okay? So if you haven't done it for your first 10 cards, even though this was in that module, do it for your first 10 cards. Yeah?
The mama sheet, technically, maybe it's in the context, but if we do the etiological agent, and we know the diseases, are you gonna ask something related to like what's the etiological agent or the disease?
I will ask this plus other things on the cards as well. But this at least gets you going. Do you have a question back there? I'm hearing a lot of chatter. Okay, all right. So please do these. These will get more complex as the semester goes on. At the end of the semester, you're gonna have, how many cards? 60 that you gotta know. You don't get to use them on the exams. So your mama sheet is gonna be humongous. So start small, okay? Start small practicing with this, okay? And the Quizzy Wizzy a week from today will look a lot like the first Quizzy Wizzy. Here's a thing, answer A, B, C, D, or E. What's the etiological agent? What's the common disease name? What's this? What's that? Okay? So, I asked systems, some signs and symptoms, okay? We're not even getting into a lot of things, and you can use your cards on this. But as we're transitioning to learning the material on the cards, help with the mama sheet. Get that going, that helps, okay? Any questions about this? Yeah. The rubber's meeting the road, isn't it? Oh yeah, it really is. But you can do it. You can do it. It's about choices, yeah.
So each etiological agent with all the diseases goes on one index card? Or are we
Yep.
doing all of it?
You're gonna make your disease cards as instructed in that PowerPoint in the handouts, how you make it.
What I need for like the mom.
Yeah, but
For the
sheet,
mama sheet, you can make a sheet like this, okay?
Is that,
And for the
for
mama sheet?
example, is Staphylococcus aureus, is that one index card?
Yeah, that's one index card.
Okay, cool.
Yeah. So how many should be on your mama sheet right now? 10. How many should be by next week? 20. Yeah, okay. Yeah.
So, I think what she's asking is pretty much what I was asking. So we're just gonna have this. We're not gonna need like prevention or any.
No. You're gonna do your disease cards. This is kind of an index card, so
For the
you
mama
can. This is the mama sheet. It
Okay.
acts as an index for all of the diseases you're doing.
Okay.
Okay? Does that make sense?
Yes.
Okay. Can you use the mama sheet on the quiz? No. Your cards. Yes.
So it's based, each like table's based, or not table, each like row's based on disease rather than the agent.
It's on the agent. So if you are looking at the end, you're going to have a list of several agents here, right? Okay? Then you can put all the disease and then this. And hopefully, most of the time you're dealing with the same systems. Yeah. Yeah.
For the disease cards, these ones have to be handwritten, right?
I can't hear you.
These disease cards, they have to be handwritten. We can't type them.
Well, I'd rather that you hand write them for a couple of reasons. You learn more when you hand write them. If you didn't get a perfect score with typed cards, don't do it. It's not working. Okay? Does that make sense? Yeah, okay. Yeah. Is that cool? You can do this. I'm telling you, you can do this. Just make sure you get, it's all about, time. It's a time thing. But, you're all smart. You're all here. You made it this far. You're going to do this. You're going to be fine. Okay. Any other questions on disease cards and mama sheets? I know it's painful starting out, but you'll get the hang of it. You'll get the hang of it. Yeah? Okay. Why do you look like you just got beat with a stick? Yep.
That's very specific.
Huh?
That's very specific.
What is very specific?
I beat my stick.
Yeah, well, I guess I could have said bit by a dog or something. Or, yeah? Or,
Thrown through the ringer.
run through the ringer.
No,
Yeah.
thrown through the ringer.
What is it?
Thrown through the ringer.
Oh, thrown through the ringer. Yeah, that squeezes all your fluid out. Yeah. Yeah, it's not tough. If it was easy, everybody would be a nurse or a dental hygienist. If it were easy. we wouldn't have a nursing shortage, right? Yeah. Yeah. Hard things. You can do hard things. Yeah. Is this hard? Hell yeah. It's hard, right? It's hard. It's a challenge. But that's how you get better. That's how you get better. Yeah. Make sense? Yeah. Cool. Okay. So yeah, you can do this stuff. All right. Let's see our module. Let's go back to eukaryotes. When we last left our superheroes, a galaxy far, far away. Where did we leave off? We left off with the on slide 17. What was slide 17?
I think we were on fungi.
We were right there? Okay. Hey, that looks good. Mitosis, right. Oh yeah, and I was gonna ask you. Okay, so let's review mitosis. Okay, first of all, what are the stages of the cell cycle? This is Bio 1 and anatomy, physiology. What is the cell cycle?
G1, G2.
Metaphase.
Oh, no.
Oh.
Oh, okay, we got cell cycle here, right? Okay, let's remember cell cycle before we even start about mitosis. Okay, what does M stand for? Mitosis. What does S stand for? Don't all answer at once. What does S stand for? I hear a lot of snakes. Okay, synthesis of DNA, right? This is nuclear. This is what happens in the nucleus, okay, during S phase. What does G1 and G2 stand for? Growth phase. So they're growth, 1 and 2, okay? These are things that are happening in the cytoplasm. They're not nuclear specific. This is happening in the nucleus. Everything in the cell shuts down while this happens, okay? All right, great. So far, so good. How long does mitosis usually take? How long does mitosis usually take? Ooh, 1 hour. S phase, 1 hour. The cell cycle is usually 22 to 26 hours. So where is most of the time in the cell spent? In growth phase, right. In growth phase doing cytoplasmic things, okay? Transcription stops here, transcription stops here, okay, because you're just doing DNA replication. Translation stops, okay? All right, that would make a wicked matching question, wouldn't it? Okay, any questions on the cell cycle before we go on to mitosis? Okay, off we go. All right, when we talk about mitosis, what are the phases of mitosis? Come on, this is review. Prophase, metaphase, anaphase, telophase. Okay? Now, I'm going to assume that you know what happens in each of these phases. Okay? Because you've had it before. Bio 1, anatomy. This was on the first exam in anatomy, right? Okay? You'll say, where's interphase? Interphase is right here. Okay? That is interphase. Okay, so let me ask you some questions and see if you can remember some of this. Which phase here can you first see the chromosomes? Who said that? Prophase. Did you get it, Tyler?
Yeah.
Good. Prophase. Okay. when are chromosomes duplicated? S phase, right? That's what it is. S is copying DNA. Okay. When are sister chromatids separated? When are they separated? Anaphase. Okay. Wow. Okay. All right. Oh, there's one other thing on here is cytokinesis, right? This is where the cytoplasm divides. Okay, where do sister chromatids, when do they line up?
Medicine.
In metaphase, yeah. If this isn't coming real quick, put this. This is number 1 to review. You've got to know mitosis and cell cycle. Is that cool? Good? All right, any questions about that? There are tons of tutorials on mitosis and cell cycle. I think I put some in there for you. If not, I will have to go back and look. But yeah, it's, this is stuff that you should know, okay? Is that good? Okay. Okay, principal eukaryotic microbes. This was a question on the exam. It was a true-false question for one version. It was asked if what the domains, how many were prokaryotic, right? And there's only 2, right? 2. Bacteria and archaea. This is eukarya, and here's our 4 that belong here: Protista, fungi, plantae, and animalia. We're not going to spend too much time on plantae because are they medically significant? No. Okay? Good. Okay. Let's take a look at all of these. Okay. Fungi. These are creepy. Love them, but they're really weird. Okay? I once met with the head of infectious disease at City of Hope. We were at a meeting, and I asked him, and I said, you know, what is the most difficult infection to treat in immunosuppressed cancer patients? And what would you say? What would you say would be the most difficult infection to treat? Yeah, something that's endospores and the funguses, okay, the fungi. He said, when we have a patient, especially that's had a BMT, a bone marrow transplant, that gets a fungal infection, they never overcome it, okay? It's important to know your funguses and your fungi. Make sure you know them and understand their lives, because as far as medicine goes, we don't have that many medications to treat fungal infections. We can suppress them, but we can't ever really cure them, okay? And with climate change happening, more fires, things like that, you're going to see more fungal infections. We're already seeing a spike from the fires in January, okay? So let's talk about these fungi. They're weird. 1.5 million species is quite a bit, okay? So what can they be? They can be unicellular, multicellular, what? Microscopic or macroscopic. Good. Okay. What are these here? You ever had these? No. They're very expensive. They're actually more expensive than gold on a per weight basis. Yeah. They're morels, truffles. Yeah. Oh, yeah. Kind of cool. All right. So, what are their cell walls made of? Chitin. Please do not say chitin. Not only is your mom going to get upset, but people are going to know that you don't know the pronunciation. It's chitin. Okay? They're heterotrophs. Okay? Remember, and so if they're heterotrophs, they're going to be of medical importance. They're aerobic or facultative anaerobes. Optimal acidity is pH 5. They cope with dry, poor conditions. They're colonizers, okay? Now, they have hyphae that are septate or aseptate. Septate means you have like breaks in it. These mean that they're aseptate, okay? And they produce spores. And allergies and toxins are a big problem with this group. Oh, are they ever. Okay, any questions so far? Got all of that? Okay. Yikes. Okay. They're really pretty. Yeah, okay. So most are saprophobic, not pathogenic, which means that they're going to be usually eating some dead or decaying material. Okay? Some are plant pathogens, and the hyphae grow into their food. Okay? And I'll draw that. In fact, I'll do that right now. Draw what that looks like. Okay? When fungus starts, let's talk about a block of cheese. Here's a block of cheese, okay? And in my house, if we grow mold on the trees, what did Mama say? Cut it off, the rest is good. What was she trying to do? Kill us, okay? Totally kill us. Save money, yeah. Okay, you don't see fungus coming to the surface unless they've run out of food in here. Okay, so what happens is a fungus comes to the surface and then they release spores that hopefully go invade another little block of cheese. Now, I grew up poor, so yeah, of course, you know, the bread's moldy, cut the bread moldy part off, the rest is good, honey, eat it. And it'd be like, okay? Why? Because in here, there are a ton of hyphae. So what happens when you talk about infection is a spore will come here, and then it will start growing, usually out in the form of a circle, hyphae. Okay? And if we look at the tip of the hyphae, okay, so this is growing out from the spore that germinated here, okay, there's a bunch of enzymes that are secreted to the environment to dissolve things, okay, to dissolve whatever that's crawling in. If it's crawling in your skin, these enzymes are usually keratinases and dissolve your skin. If they're in cheese, these hyphae are going to have enzymes that dissolve things back to their monomers where it can be reabsorbed. Okay, so they're going to reabsorb all the monomer units, or, you know, so, and then what happens? The hyphae then grow. And then they do the same thing. This is called extracellular digestion. Okay? Extracellular digestion. It's outside, okay, of the hyphae. All right? Now, let's use this in medicine. One of the things, what is one of the symptoms of a fungal infection? Especially on the skin, or the nails, or the feet, or your groin. What is it? Itchy. Everything's itchy. Why? Because these hyphae are dissolving your keratinase and tunneling through your skin, which irritates the nerves. Okay? So when you're itchy, you know that hyphae is growing, right? Cool. Gross, but cool. Okay? Now, they like acidic conditions. Your skin is acidic. Why? Because you've got a bunch of sebum on it, and that lowers the pH. Okay? So, let's take a look at this. All right. So, tips secrete powerful extracellular enzymes. What is this? I put absorb products of minerals and ions, important decomposers. Yeah. Yeah, we need the fungus. Yeah, for sure. Any questions about this slide? You good? Okay. So let's do some classification. We've got 156 known that we are assimilated with right now, known species. They're classified by how they store their spores. Okay? That's how they classify them. So, what belongs in here? This is bio 1, right? Zygomycota or mycetes, okay, Ascomycetes, Basidiomycetes. And then we have Deuteromycetes, which are the imperfect fungi. Because their spores are so weird, we don't know how to classify them, so they get thrown into this group. Okay? So, how many of you remember this from Bio 1? Okay, a few people, that's good. Okay? So, let's talk about the fungi. Here we go. This is Zygomycetes. If you've seen bread mold, that's it. Yeah, that's it. Okay? They are recognized by these things called zygospores. Okay? So the hyphae will come together and mate and produce some spores, and this will grow above the fungus. Why is it important that the spores be released above where they're living? To spread out. Right, spread out. And so this is what happens, is that these mature, they look dark. That's why red mold, when it's mature, looks kind of dark. And what happens? The zygospore breaks open and the spores go everywhere. So if you have a bag of moldy bread, you've got billions of spores in that, right? Anybody allergic to mold? Mold is a fungus. Yeah. Some people are definitely allergic to this. So, yeah. So bread mold is a good example of Zygomycota. Okay. All right, let's talk about Ascomycota. Okay, Ascomycota, what it happens? It stores its spores in a sac called an ascus. Okay, that's what it does, is it stores there in these little sacs. Okay, so examples would be yeast and truffles. Okay, there. I know a song about yeast. I brought my cello in one day and played a song about yeast. I'll see if I can bring it in. And we'll sing about yeast. You're like, boy, she's drunk today. Okay. No. Just music and things to help you remember things is so much better than just trying to memorize it black and white. Okay. So these are morels, cup fungus, flask fungus. These are some of the sac fungus. And you can see, what is the name of the sac? Where they keep their spores? An ascus. Yeah, there's the ascus. Okay, here we go. Okay. Now, this one we're pretty familiar with. If you have a pizza and you put a mushroom on it, make sure to put this one on, not this one. This one's deadly. This one, not so much, but it could be. Not sure. The mushrooms that look perfectly healthy to eat, and the deadliest one, the Anomaides, look the same, unless you know what you're looking for. They're both white with a cap. So, okay, Basidiomycota, Basidiomycetes. This is the basidium. It attaches to the underside of the gills here and releases spores by that. Now, when you get commercially available mushrooms, okay, they're pretty young. They haven't made all of their spores yet. But if you were to look at wild mushrooms, yeah, you can see the spores. You could tap it and the spores will fall out. Okay, so it's the basidium that's here. Okay. Every Thanksgiving, especially up in Northern California, people decide to go mushroom hunting for their dinner. If you don't know what you're eating, it can kill you. And it's not a sudden toxicity. They can feel fine for a couple of days, and as the toxin starts to affect their liver, they get sicker, and most of them die. This past Thanksgiving, there was a family of 4 up near Santa Cruz that decided to go mushroom hunting, and they didn't pick the right mushrooms, so they died. Okay? I get my mushrooms from the grocery store, and even then they look a little sketchy. So, just saying, if you see them in your yard, don't eat them. Please don't eat them, okay? All right, don't eat things, mushroom. Don't eat wild mushrooms. Okay, so drink water, don't lick bats. Don't lick them. Why would you lick them? Okay, what's rule number 3? Don't eat wild mushrooms from your lawn or some of your friend's lawn or something. Or at a Grateful Dead concert. I don't recommend that either. Wow, my cousin got so out of it. And why? Because those mushrooms produce a neurotoxin. He was higher than a kite the whole time. And I'm like, he didn't tell me that that's what he did. And I'm like, what's wrong with you? Yeah, took him 3 days to come down. Why? Because everybody metabolizes toxins different than everybody else. Oh well, he's in jail now, so we don't have to worry about him. He's in prison. Yeah. Yeah. Okay. Imperfect fungi, which is Deuteromycetes. Now you can see why we don't classify them in a group. They're not in a sac, they're not in a basidia, they're not a zygospore. What do we do with this? Don't know. We'll keep them in this group. Okay. All right. So, now let's get to the infections. Okay, when you hear the term mycoses, think of a fungal infection, okay? And we've got two flavors, okay? We've got deep mycoses, okay, which brain, lungs, heart, I've seen ear, liver, spleen, kidney, okay? And then you get cutaneous and subcutaneous infections, okay? All right, which do you think are harder to treat? These, the deep ones, yeah, they're really hard to treat. Okay, so we're going to talk about some of these systemic infections, and then we'll show you pictures of some of these dermal infections, because once you see a fungal dermal infection, you should be able to recognize it. Okay, so let's talk about systemic mycoses. Okay, these are facultative pathogens. Okay, bless you. They live in the soil. Most of the fungus, when we talk about infections going from into humans, it comes from soil fungus. Okay, boy, you want a good infection? Cut your hand open and go dig in the dirt. You'll get the nastiest infections. Okay, yeah, crazy. Okay, and for systemic infections, a lot that we're going to talk about two that are inhaled. Okay, one is the histoplasmas. Okay, and it comes from spores. Okay, and the disease usually comes from the lungs, not from the gut, but from the lungs. Okay, so we're going to see two fevers that are caused by inhaling soil spores. One is valley fever, which we're seeing an increase of right now because of the fires, and the other one is Ohio valley fever. Okay, you're going to find those on your disease cards. All right, those two diseases. Okay, and what happens? The spores get into the lungs. The lungs are warm, they're moist. Okay, and what happens to the spores? They germinate. Okay, if you could see x-rays of what this looks like, it's usually something round. You look at fungal infections, you usually are seeing something round. Why? It's the same reason you see it with cheese. Okay, the spore comes here and then it starts to germinate. Okay, is that cool? Okay. All right, yeah. Pneumocystis pneumonia, histoplasmosis, which is Ohio valley fever, and then our valley fever. Okay, let me see if I can find an x-ray. I should have found an x-ray. See if we can bring up an image of that. Okay, here's it. See it right away. You see it? Yeah, yeah. Okay, this one's a little harder to see, but you can kind of see those images. When you start to see something round, what should you think about? You should think about, oh yeah, there's only one exception. The one exception is a disease called leishmaniasis, and if you've lived in the Middle East, you're aware of what leishmaniasis is. Leishmaniasis is a protozoan infection that you get from the sandfly. So what kind of transmission is that? Vector transmission. Now sandflies are a quarter of the size of normal mosquitoes. They're very tiny, you don't see them. They bite you, they have the trypanosome in them that causes leishmaniasis. And you see it at the VA, okay? You'll see these round, if you've got cutaneous leishmaniasis, you see round sores. And if you haven't had any experience in tropical medicine, you'll misdiagnose those. You'll say, oh, it's a fungal infection, when actually it's leishmaniasis. So that's why it's always good to culture, okay? If you're gonna work, how many are gonna work at the VA or Loma Linda or something? Okay, so you're gonna see this, okay? I had a student that had leishmaniasis from the Gulf War in 2006. They misdiagnosed it for 6 months. Kept giving her antifungal. I said, you know, hey, culture, you gotta culture it. They did, what did they see? Leishmaniasis. They ended up having to do surgery to cut it out. Okay, so, you know, when I'm on your case all the time about details, do you see why? Yeah. People's health are at this. This poor girl suffered. And antifungals for 6 months makes you very ill. Okay? And her doctor could have said, well, I think it's fungal, but let's take a scrape. Let's take a biopsy. They should have known in 2 weeks, right? But instead, what did she do? She suffered for 6 months. She lost 20 pounds on these antifungals. You know? Yeah.
Why do you believe that some doctors tend to misdiagnose? Is it because of the lot of work they have, or they just don't care?
I don't think they just don't care. I think U.S. medicine is in deep trouble because we lost a lot of people from death and resignations from COVID, and the insurance situation is almost impossible. So they have to really see patients every 7 minutes if they're going to be able to make any money. And these are people that have $300,000, $400,000, $500,000 of debt, right? Because they went to medical school. And the insurance companies don't want to pay, right? The insurance companies really don't want to have to pay. We've seen that. And so I think it's just a perfect storm. And what COVID did, it just kind of opened it up into all the problems that we have. And they haven't been resolved, right? So I know a lot of good doctors that left are working in other countries at this point. Or they go someplace where they're not limited so much by insurance. But then that ends up costing us lots of money, right? So it's horrible. It's absolutely horrible. And
It's just a matter of having to work fast.
you have to work fast and you have to keep your costs down. And so I don't think nobody goes into medicine because they don't care. All of you have huge hearts. That's why you're in here, right? Because you want to take care of people. You want to help people. But the system whacks, these people down, right?
Since that happened, you said, right, she got it after. Did she sue? Because technically that's their fault. She could have lost her life because of that. And now the insurance is losing double the amount of money.
Yeah, you can sue, but it will take 10 years. And what are you going to sue for? Oh, I got sick for 6 months? You have to prove damages. And then it gets to sit in the court where the lawyers make money. So it's better just to do the right thing at the right time, And right now, for a lot of practitioners, and those who are working right now, it's really tough. The SNFs took a hit. Is anybody working in SNFs? Okay. How's the morale there? Yeah. Not good? Yeah, it's really hard. You're going into medicine and the worst I've seen in 30 years. But that's okay. You're going to make it better, right? Oh yeah, that's why we're here. Is to make it better and to make better decisions and to, you can influence the area around you. You may not be able to get the system, but if enough of us are influencing the system around us, we'll see change, right? Yeah. Do you realize we could throw off ChatGPT so badly? Because how is ChatGPT run? It takes the information that you throw in there and to make algorithms. It's just math. So could you shift that algorithm? Absolutely. Have you thought about this? Yeah. Yeah. Question everything. Question everything. Yeah. I had a dream about this actually, about shifting the GPT thing. Huh?
I said our dreams are so different.
Oh yeah. What did you dream about?
I stressed that I didn't bring my disease card.
Oh, that's a nightmare. Oh my gosh. Yeah, I dreamt about two things. I had a meeting with NASA Friday from 4 o'clock until 9 o'clock Friday night, and so I dreamt about mitochondria all night. Boy, it was cool, man. It was so cool. So yeah, another day. Okay. Another day. Yeah. Okay, so let's look at dermatophytes. Okay, they're cutaneous and subcutaneous mycoses. They secrete the enzyme keratinase because that's what your skin is made of, right? And they digest hair, skin, nails. And here's some of my favorites: the tinnias, ringworm, jock itch, and athlete's foot. Woo! And what do you notice about these sores? They're red and they're spherical. Yeah. What does this look like to you? If you had to guess from our, it's ringworm. Yeah, it's ringworm. Yeah, totally ringworm. Okay. All right. Let's look at some more tinnias, which are the like ringworm. Okay. Yep. All these spherical things. The hardest one to see though is in the nails, because the nails is a 3D matrix, and so you can't see all of it at once, and so you can't see it. But that's what it looks like in fingernails. Okay. You see it on head, skin. Wow, that is a perfect sphere. Oh, beautiful. Okay. Yeah, you're like, no. Okay. Here's an opportunistic fungi. Candida albicans. What does this one cause? These are yeast infections. Okay? They're opportunistic. Why? Because you've always got yeast in your system, okay, in your vaginal tract, okay? But when they get out of balance, that's when they're opportunistic and take over. You don't always, what are the times that you get it? Well, I'm not going to ask you personally, but in general, okay, when do you see females that get yeast infections? When they're sick, when they've been on antibiotics, right? Because what happens? Bigger than the pH, it throws all the healthy bacteria you need there, right? You killed them off with the antibiotics, and who comes in? The yeasty beasties, right? Okay. Yeah. Yeah. It's a miracle we make it through the day. Okay, let's talk about some people that made it through the day really high. Okay. These are fungal intoxication. When you hear intoxication, what should you be thinking about? Toxins. And what are most toxins? This was a question on the exam. What are most toxins? Proteins. Yeah, they're proteins. Okay? So, yeah. This is really creepy. Don't dream about this. Okay? But, bless you, ergot poisoning, E-R-G-O-T, ergot poisoning, that is a poison that is made from fungus that grows on rye. So here's the ergot that's growing on the rye, okay? All right? And this claviceps, claviceps is the species that grows on rye. Okay, do you remember the Salem witch trials?
Oh, sure.
Yeah, we were all there. No. But what happened? A bunch of people went cuckoo, and they said, "Oh, they're witches." And what? You're a witch. You're a witch. You're a witch. And then what did they do with the witches?
Killed them.
They killed them. Yep, they burned them alive. Yeah. Well, what we know now is there was a lot of contamination on their rye, which they ate, and they didn't know about yeast or funguses or anything, and the ergo poisoning got them. And you can see how it's depicted in art, right? They went absolutely crazy for this toxin. Now, what do you do to treat this? You can't. It's a toxin. It has to be metabolized. Okay? Does that mean you go permanently mad? Sometimes. Okay? That's why you inspect seeds like wheat and rye and that. So make sure that there's no fungus on them, otherwise you're going to get fungal intoxication. Okay? These are not cells, these are toxins, which are proteins. Okay? Okay, this is my favorite one, aflatoxin B1. Aflatoxin B1 is a fungus that grows on peanuts, and it is the most potent cancer-causing toxin known that we have found. Yeah.
How do you spell that?
Aflatoxin? Aflatoxin B1. Okay, aflatoxin B1. Okay, what does this toxin do? This toxin lives on peanuts. Okay, when you ingest this toxin, it goes right for the liver cells, it goes right for chromosome 17, it goes right for the P53 gene, which is the most mutated gene in human cancer, and it makes a mutation in a specific location. Okay, that's what this toxin does. Okay, most of us eat this stuff, right? Something like that. Okay, on the label, go home and check this. It says what? Refrigerate after opening. Do you have your peanut butter in your fridge? No.
Every day.
Okay, we're lucky because we live in the U.S. and in the U.S. we inspect peanuts and we process them. We process the shit out of them, don't we? Let's add some sugar and some salt and some stuff in there to keep it all nice. So we're lucky. Most of the peanut butter you don't have to worry about in the United States because it's processed within an inch of its life. Okay? But you leave it open, and if there's any fungus that will produce aflatoxin, aspergillus, it can fall in there and make its home. That's why they say put it in the fridge. Okay? Put it in the fridge. Why? Because, yeah, you won't get cancer from aflatoxin B1 for 20 years, but who wants liver cancer? I don't. Yeah. Okay? Now, if you lived outside of the United States, there's no guarantee if they're inspecting. Okay? In the country I lived in South America, they didn't inspect their peanuts. So did I eat any? No. No. I ate worms, but I didn't eat peanuts. I didn't want liver cancer, but worms, hey, we can treat that. Okay. So, what causes this? Aspergillus flavus. There's aspergillus. You can see it. Okay. Aspergillus. Guess what? Go to your book and look it up on how to spell it. Because I've asked you to fill in as many blanks as you can before you come to class, right? Okay, good. Aspergillus. Yeah. Okay, let's do another fungal intoxication. Woo woo. What is this? This is, should have put a shamrock on here. Happy St. Patrick's Day, right? Okay? Yeah, and what do? We use Saccharomyces cerevisiae to make beer. And if you decide you want to be, was that a ghost? We're good, we got time. Relax. Okay, so if you want to make money as a microbiologist, become a brewmeister. Okay, the microbiologists that are in charge of brewing beer for major companies, for major brew houses. Okay, interested? Go to UC Davis. UC Davis has a program to teach you how you can make a lot of money. 200, 300 if you're really good. Not an hour, 300,000 a year. Why? Because in order to get these yeasty beasties to do what they need to do to ferment and get the flavors, you have to know a lot of chemistry and a lot of microbiology. And so Davis offers a program in brewmeister certification and also viticulture and enology, which is the wine side. Because with wine, it's a lot of the microbes that are on the surface of the grape that give it. But yeah, but what are you doing? Ethanol is, they go through anaerobic respiration, they make alcohol and CO2, yeah, and you drink it, and what happens to your thoughts? They get a little funny, okay, why? Because it's a toxicity. Drinking is a toxicity. Yeah, so, yeah. Okay. Any questions on the toxications? We got ergo poisoning, aflatoxin B1, and ethanol.
Isn't ethanol a byproduct of yeast?
Of yeast anaerobic respiration, yes. And so what do? Well, we're going to make a drink that makes us feel funny. Yeah.
So is
But
that
it's an intoxication. Yeah.
So is that how they make gasoline too?
How do they make gasoline? No, gasoline. You mean like biofuels?
E85?
E85, yeah. They use the same kind of process where they're making long chain. Well, actually, it's not that long chain compared to what we do in biology, but yeah, octanes. So yeah, you only need 8 carbons. So why not? Okay. Let's talk about the protists. There are 3 groups of protists. Heterotrophs, autotrophs, and mixotrophs. Okay, those are the 3 groups of protists. We're going to take a look at the autotrophs. The autotrophs are kind of cool, but not medically important unless you look at what they're producing. These can produce toxins as well, okay? They're photosynthetic. So they're not going to be, you're not going to say, oh, I've got a diatom infection. No, you don't say that. You won't see that. But this is a dinoflagellate, okay? What it does cause is something that we see in both freshwater and seawater called red tide. Has anybody seen a red tide? How many seen one in real life? A red tide, yeah. Okay, you guys have to get out more. Okay, you have to get out more. Put this on your bucket list, okay? We've had a couple of really big red tides. Okay, let's show you what it looks like. Okay, here we go. Oh, and we got another. Oh, yeah. Okay. Now, why don't we have any sound?
You have it muted.
Do I? Oh, I do. Okay, here we go.
Let's get up to Rich Prickett, who's above it, the Sky 5. Rich?
This is in October.
Rare site here in Santa Monica. We're talking about the red tide or red algae that is bloomed here in the
It's not
west
poop.
side of LA from Santa Monica all the way down to Marina del Rey. Well, right now here and kind of show you a wide view. You can kind of make out some of that red tint in the water here. It's a pretty large bloomier. of
Oh
that
yeah,
red
look at
algae.
that. That's big.
And no word on how long
I got somebody
this is
swimming
going to
over
stick
here.
around, but folks that are familiar know that this is can be harmful to people, marine life, birds, mammals that congregate here on the beaches. So this is right around Santa Monica Pier. We're not seeing any formal closures on the beach, but for the most part, people know to kind of stay out of them.
Okay, so it smells like broccoli and old pennies and old socks, but
So why
but
does
why?
it happen?
Huh?
Why does it happen?
Because the temperature and nutrient conditions of the ocean are just right, and there's no way to really. Let's see if I can show this. Okay, here we are. But see this? Yeah. So what happens? During the day, it smells bad and looks red. But at nighttime, when these little microorganisms, these dinoflagellates, get agitated, they fluoresce. Yeah. Yeah, it's not I don't know. I've swam in it. I've surfed in it.
Swam in it?
Oh, yeah.
I thought that was dirty water the entire time.
Yeah, if you walk on the beach here, your feet will light up. If you're a dude, you can pee in the sand. Huh? Yeah, that is a red tide. Not all species bioluminesce like this, but you have to see it one time in your lifetime. Okay? You gotta see it. Oh my gosh. And it's all of this, the dinoflagellates. They cause red tide. They're always in the ocean. They're always in the ocean. And then there'll be a temperature shift or a nutrient shift, and their numbers will just explode. They call it an algal bloom, and that's what you saw. It's billions of these. They're so thick, they have a red eye spot by their flagella so they can orient themselves to the light. And they're so thick, it looks like they're red. Okay? But you got to see this. Now, on the west coast, the species make a toxin called domoic acid. Domoic acid is really bad for the baby seals and the mama seals and stuff like that. But for humans, you have to ingest a lot of it to get an effect. Okay? That's why I swam and surfed in it, because, YOLO. I'm going to do that. Okay? Did I get sick? No, I didn't get sick. But on the east coast, if you see a red tide, those species of dinoflagellates they have make toxins that are deadly to humans, and so they'll close the whole beach all summer. Okay, so it just depends. There are some bioluminescent beaches. There's one in our lovely Puerto Rico where you can go and it bioluminesces all the time. It's not as deadly, okay? But these are dinoflagellates. Isn't that awesome? Yeah. What? In Puerto Rico? It starts with a B. I have to look it up. Yeah. But it's, huh? Yeah, I think it's on the south west corner of the island. If you look at bioluminescent beaches, it will pop right up. Okay. All right, here's some more protozoans. These are the ones that are hard for our health. These are the heterotrophs. These are the ones that are going to cause problems. Okay? I look at this and my heart stops. What is this? This is malaria. Okay? Malaria uses a red blood cell as part of its life cycle. That was a question on the exam. What was, before COVID, what was the most deadly infectious disease? And people put heart disease. Heart disease is not infectious. What's the most deadly disease on this planet that's infectious? Malaria. Yeah. Okay? And you're like, well, I won't be in the tropics. Well, the climate's changing. The mosquito that carries malaria is here. It's only a matter of time. Okay? So here, who's this? This is an amoeba. Good. Which one is this one? Any ideas? This is the one that causes giardiasis. Yeah. Okay. So, I think your brain is full. We'll stop here. Let me mark where we are. Okay. And we'll start with the protozoans. Okay, before you pack up, did you learn more by just focusing on what we're doing? Okay, Keep that up. Now,